Hi everyone, and welcome to this lecture. So here we are going to talk about the particle swarm optimization algorithm, which is a very interesting algorithm applied in combinatorial problems with real valued vectors. So this is a heuristic based on the collective behavior of animals, especially birds and insects. So here we have bird flocks and insect swarms mainly. And it was proposed by Kennedy and Eberhard in the 19th, inspired by the studies that model the social behavior of animals. And because it was inspired first on the social behavior of animals, one of its applications is to simulate animal behavior, is to produce animations that simulate animal behavior. In a lot of cartoons and movies, instead of producing the movement of every individual animal in the flock or in the swarm, they use this algorithm to simulate this collective behavior. It is also applied in many scientific and engineering problems, for example, design of antennas and optimization of energy systems. It is also used in the optimization of mathematical functions as well, mainly nonlinear continuous functions. So here we have a representation of a bird flock. So here we see the collective behavior of animals, in this case birds. If an animal from the flock changes direction, it doesn't change the direction instantaneously, because in physics we have something called inertia. And the same thing will happen for the other animals as well. So here we have two forces, the new direction and the inertia, whenever the animal changes direction. And here we have the representation of the new direction from the rest of the flock. So here we have the animal inertia, and here we have the next direction in red. Now let's make an analogy for this problem. Let's suppose that here we have 6 people, and in red right here we have a heat source. The people cannot see the heat source, however they can sense, they can feel the heat, and they can realize the changes in the intensity of heat. The blue circle represents the closest person, the person that is closest to the heat source. So this person is feeling a more intense heat from this direction, from this position. So the other people will follow this person. Now that they have changed position, they realize that this person right here is the one that now feels the more intense heat. So they try to follow this person, and by following this person, by, for example, walking 3 steps forward, they realize that this person right here is feeling the most intense heat, and they tend to follow again. Now this person is the closest person to the heat source, and based on this behavior, based on this heuristic, they can find the heat source. The particle swarm optimization used this heuristic to find an optimal solution. So here let's suppose that we have a change in direction. Now these new particles right here will also change direction. However, it will not happen instantaneously. So here we have the inertia of the particles, and here we have the new direction. This inertia allows for a more efficient exploration of the search space. So here we have no inertia, so let's suppose that this particle right here is the best particle, the one that has the best solution, and these particles right here tend to follow this one. So here we will put no inertia. So here we don't have inertia. So this is a search space. Now we are going to see the effect of inertia. All of them will have some level of inertia, and this level of following their own direction has a random weight, which we will see later in next classes. So here we have inertia. Look at this area right here. it is bigger than the area when we don't have inertia. So here we can see the difference, the comparison. When we don't have inertia, we have a less efficient exploration of the search space. Here with inertia, with random weights, with random influences of the inertia for each particle, we have a more efficient exploration of the search space. So this was the lecture about the introduction of this algorithm. In the next lectures, we are going to see the main steps of the algorithm and how it works in detail.